Good morning to all. In this class, we are going to discuss about the topic synchronous generator. Myself, Raj Sharan, Assistant Professor, Place and Islamic Project Technology, Tiruchendur. So, students, today we are going to discuss about the following points. So, in this unit, for synchronous generator, we are going to cover the following topics. So, first one is construction details, types of rotors, EMF equation, synchronous reactants, armature reaction, voltage regulation. In that voltage regulation, we are going to discuss four methods. One is EMF method, MOF method, SPF method, and AC method. And the next topic is synchronization and parallel operation. And synchronizing torque and change of excitation and mechanical input. Then two reaction theory, determination of direct and quadrature axis, synchronous reactants using self-test, and operating characteristics and capability curves. So these are the topics is covered under this synchronous generator. So basically, we have to discuss about AC machine. So in that AC machine, basically, classified into two types. One is synchronous machine, other one is asynchronous machine. So synchronous machine again we have classified into two types. One is synchronous generator and synchronous motor. The synchronous means the machine is the machine speed is actually run with the your stator or rotating magnetic field speed. Then another one is asynchronous machine. So which means that your machine speed should not the same as rotating magnetic field speed, which is always lesser than the rotating magnetic field speed. Okay. So in that induction machine also we are going to classify into the two types. One is induction generator, another is induction motor. So the synchronous generator, the primary is source is electrical energy. Okay, normally we know that generator, which is a machine used to produce the electrical energy. So for that, it is an act of source of electrical energy. Then motor normally which receives the energy from the generator. Okay, the output of the motor is normally mechanical input, mechanical output, and the output of the generator is normally electrical. Okay, so the main purpose of this synchronous motor is for the use of power factor compensator, which is used for the power factor correction, or we can call this motor like a synchronous condenser. Then asynchronous machine, again it has classified into two types already told. Induction generator, so due to lack of separate field excitation, these machines are rarely used as a generator. Okay, so this is the machine is very rarely used, which is not in the practical case. Induction motor in many industries, about 95% of industry they are using induction motor for their application because of the less maintenance, less power losses, and the user friendly. So all the characteristics will be very fine, and we can use this machine for lifelong. So now we are entering into the synchronous generator. So synchronous generator is nothing but the arrangement of field and armature winding. Okay, so in this machine we are having a stator as well as rotor. So in this machine, the field coil is placed in the stator part of the machine, and armature is nothing but the rotating part of the machine. Okay, so this machine will be classified in the following types. One is stationary armature and rotating field. So this machine is suited for above 5 kVA system. Second one is stationary field and rotating armature. So this is suitable for below 5 kVA machine. Okay. Then advantages of stationary armature, then rotating field. Okay. So why we are going to discuss these things means, so already in your previous subject electrical machines 1 or DC machine transformer, so you studied about the field coil of the DC machine will be station 1, and the rotating part of your DC machine will be an armature. Okay, so in this synchronous machine, so we are going to change this field coil and armature coil position. So what are the advantages we have for stationary armature rather than this rotating field? So we have to discuss it. So first one is for high voltage AC winding, its insulation is not subjected to centrifugal forces. So we can give the better insulation to the system. Okay, if you are fixing your armature is stationary, so we can go for this stationary armature. Then easy to collect large current from the stationary member. Okay, so if your armature is rotating part, so we need a brushes, separate brushes we need, and we have some filterings or we need some commutator devices. Then only we can collect the current from the output part. Okay, so this is a problem for when we have a large machine. Okay, so the collection of current in the stationary part of armature is very easy, and this is the bigger advantages than for a stationary armature. Then rotating field makes overall construction simple. Okay, if you are going to the rotating field, so the entire machine construction will be very simple. Okay, so in the armature parts only, the construction is very complicated. But in the case of the field coil, which is not a complicated, so just we are going to excite the field coil to create the electromagnet in the field winding. Okay, if we are having a rotating field, so this will create the very simple construction for the machine operation. Then a problem of sparking at the slip ring can be avoided. Okay, so if you are having the stationary armature, so we are going to collect the current from the stationary itself. So we do not have any type of ring arrangements for this condition. So we can avoid this very easily. Then ventilation arrangement for HV can be improved. So this is the very major problem. So if your machines does not having the proper ventilation, so definitely due to the heat generation in the winding will spoil the life of the machine. So we have to give the proper ventilation to the system. So then only all the heats which is generated inside the machine properly extracted from the outside, so we can avoid the insulation failure. Then next one is low voltage coil. DC excitation easily supplied through slip rings and brushes to the rotor field winding. So this is the another important things. So the DC excitation means we are giving separate DC supply to the field coil to excite the field coil, so that only the field winding will be behaved as a magnet. Then only it can produce as a magnetic flux. That thing will be different. So for giving DC supply to the field coil, so we need slip rings and the brushes arrangement. So we are giving very low voltage to the field coil only. Okay, so our voltage range is about 110 to 220 volt. But the output range is about 11 kilovolt to 30 kilovolt, 33 kilovolt. So this much of current we are not able to take through this slip ring and the brushes. That is very tedious process. But we can give the separate current voltage through this LV coil very easily because the slip ring and brushes are having low rating. So this low range of supply can provide very easily without any difficulty. Then so when we are going to this stationary armature and rotating field type, so the machine running is will create the noiseless. Okay, so you can avoid the unnecessary noise in the machine operation. Then air gap length is uniform. So this is very important point. So when you are designing machine, so your air gap is play a very vital role for the entire operation of the machine. If your air gap is not uniform, so definitely we are facing or we are facing a lot of struggle to running this machine operation. Okay, so this will be you have to taken very clearly. Then better mechanical balancing of the rotor. So balancing of the rotor mainly depends upon the speed of the machine. So when we are having the field coil as a rotor, so we can maintain the balance. So now we will move into this construction of alternator, both stationary armature and rotating field. So in our alternator having 3-phase winding on the stator and the field winding or DC field winding on the rotor. So stator is nothing but this is your stator structure. Okay, see this. So this is stator. So all the stator having separate type of slots. So these are the slots. So here we are having the two holes. So this holes is nothing but ventilating ducts which is provided in the stator coil. So this part is nothing but the teeth portion of your slot. In between the slots we are having some spaces. In that spaces we are providing the required armature coil in the in this position. Okay, so all the coils are connected and linked together and it will create the stator portion of the alternator. Okay. So the explanation is nothing but a stationary part of machine. So this is a stampings. These all are stampings. So the stampings built the steel lamination for the slots to hold the armature conductors. So this is the place where we are going to place the armature conductor. The armature winding is connected in the star part. So star connection and delta connection we are having. So we are connecting armature assist star. So this is the cross section view of your the stator part. So this is your stator. So lamination of laminated iron core, the slots placed here. Then we are having the outer part of the machine. We are having steel housing. This steel housing will hold this entire part of your slot, armature conductor, and everything at all. See, this is end winding. So this is the outer part of your machine. So this is your end winding. Okay. So we are having a very length of coil which is continuously fixed in the corresponding slots. And finally, in the star we are having 3 output. So the 3 outputs are coming from this end point. So this is called end winding. Okay. So stator details, the coils are placed in the slots already told, and coil end windings are bent to form the armature winding. Okay. So this is the iron part. In between we are having coils. So this is coil. This is the slot portion of the machine. This is slot portion. So this is the proper coil winding nature. You can see. So this is teeth portion of your machine. So in between the teeth portion we are having some small ducts. So that is the slot portion. In the slot portion only we are fixing the armature winding. Okay. Similarly, rotor, 2 types of rotor. One is salient pole type, another one is non-salient pole type. So salient pole means normally it has poles are projected, and non-salient pole means the poles are very smooth. Okay. So this is salient pole construction. So this is your winding nature. The poles are projected here, outside this. So it will create the non-uniform air gap in the entire system. And also it has a very thick lamination coil. Okay. All right, then